Consider the differential equation, the derivative of y with respect to x is equal to 2x minus y. On the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. And we see 1, 2, 3, 4, 5, 6 points. And so what I can do is, let me set up a table actually. Let me set up a table with 3 columns, one for x, one for y, and then one for the derivative of y with respect to x, which this differential equation tells us in terms of x and y. And so we can look at the different points. This point right over here, when x is 1 and y is 2, x is 1, y is 2. Well, the derivative, they tell us, is 2 times x minus y. So this is 2x minus y. So it's going to be 2 times 1 minus 2, which is equal to 0. And so if the derivative there is equal to 0, then if I were to draw a line that indicates the slope at that point, well, I would draw a line with a 0 slope. So it would look something like, let me draw it a little bit. It would look something like that. All right, let's keep going. Let's look at this point where x is equal to 0, y is equal to 2. X is equal to 0, y is equal to 2. The derivative is going to be 2 times x minus y. So it's going to be 0 minus 2, which is equal to negative 2. So how do we draw a slope of negative 2? Well, it's going to go from the top left to the bottom right. It's going to be pretty steep. So it might look something like that. That looks like a slope of negative. Let me try to draw it a little bit better. So I could draw it. Well, that's pretty good. Maybe I shouldn't use my line tool. Let me just try to draw a reasonable. So if I have a slope of negative 2, as I move 1 to the right, I move 2 down. So it should look something like that. All right, let's keep going. x1, y1. X is 1, y is 1. It's going to be 2 times 1 minus 1. So this is 2 minus 1. It's going to have a slope of 1. And so that would look something like a slope of 1. Look something like that, or let me just draw it by hand. That's actually easier. And then we have x is 0, y is 1. X is 0, y is 1. Slope is going to be 2 times 0 minus 1, which is equal to negative 1. And so now the slope is negative 1, and just like that. Notice it's less negative than up here. It's less steep. And then let's go to x is 1, y is negative 1. X is 1, y is negative 1. So it's going to be 2 times 1 minus negative 1. So this is 2 plus 1. This is equal to positive 3. So here the slope, it's going to be even steeper, but now in the positive sense. So the slope of 3 would look something like that. And then finally, we have x is 0, y is negative 1. It's going to be 2 times 0 minus negative 1, which is going to be equal to a slope of 1, which is going to look like this. It should be the same. It should be parallel to what we have right over there. And we're done. All right, let's do part B now. Find the second derivative of y with respect to x in terms of x and y. Determine the concavity of all solutions for the given differential equation in quadrant 2. Give a reason for your answer. All right, so first let's just find the second derivative. So we already know that dy, let me give myself a little bit more space actually. We already know that the derivative of y with respect to x is equal to 2x minus y. Now to find the second derivative, I just want to take the derivative of both sides of this with respect to x. So let's do that. So I could take the derivative of the left-hand side with respect to x and the derivative of the right-hand side with respect to x. And so what is this going to be? On the left-hand side, the notation would just be the second derivative of y with respect to x. And then over here, let's take the derivative of each of these with respect to x. The derivative of 2x with respect to x is going to be equal to 2. And then minus the derivative of y with respect to x, well, it's just going to be minus minus the derivative of y with respect to x. And so we could say, okay, we found the second derivative, but remember, they're saying in terms of x and y. Right now I found the second derivative in terms of, well, in terms of a constant and in terms of the first derivative. And so we can substitute our expression for the first derivative back here to have this expression in terms of x and y. And so this is all going to be equal to, let me write it over here, the second derivative of y with respect to x is going to be equal to 2 minus, well, the derivative of y with respect to x, we already know, is 2x minus y. 2x minus y. And so this is going to be equal to 2 minus 2x plus y. Plus y. And then they say, determine the concavity of all solutions for the given differential equation in quadrant 2. Remember, if you're thinking about our coordinate axes, so if that's our y-axis, that is our x-axis, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So they're talking about quadrant 2. So what do we know about x and y in quadrant 2? We know x is less than 0, and we know y is greater than 0. So quadrant 2, let's write it like this. Quadrant 2, we know x is less than 0, and y is greater than 0. And so if that is the case, so we have 2 minus 2x plus y. So this is going to be, this right over here is going to be greater than 0. And negative 2 times a negative value, well, this is also going to be greater than 0. So quadrant 2, because of this, that means if this whole expression is going to be positive, negative 2 times a negative number is going to be positive, plus a positive is going to be positive. So the second derivative with respect to x is positive, which means that our slope is increasing over that interval, which means that we have positive, we could say that our concavity, I always have trouble saying that, concavity is upwards. And if you ever forget whether, okay, a second derivative being positive, is that concavity upwards or downwards, I always just like to draw kind of our, the canonical concave upwards or concave downwards. And you can see here that your slope here is turning less negative, or you could say it's becoming more positive, it's increasing, and it continues to increase when you are concave upwards. So second derivative positive, you are concave upwards. Second derivative negative, you're going to be concave downwards. I'll get rid of this because you wouldn't want to put that on the actual AP test.